Ladies and gentlemen, good afternoon. Welcome to the 2021 International Webinar on Future Technology Development and Trends of Taiwan's Robotics Industry and Electric Vehicles. I'm Maggie Wu, your MC for today. On behalf of Bureau of Foreign Trade of MOEA, I would like to extend our warmest welcome to all of you. In recent years, for the purpose of environmental protection, governments around the world have been formulating policies on limiting the use of gas and diesel vehicles. In response to such trend, global vehicle manufacturers have also started investing and released various kinds of electric vehicles. Also, in the era of Industry 4.0, to move toward smart manufacturing, automation, and robotics are major trends to be noticed. Under such backdrops, integration of smart technology, robotics, and automation will be of great importance to the development of electric vehicles. Today, we invited experts from the industry to have in-depth discussion. In the last part of today's webinar, we'll also have a panel session, inviting all the speakers to talk about the future trend of the EV industry. And now, please welcome President of Precision Machinery Research Development Center, Mr. Yong-Xiang, to give us the opening speech.
Hi everyone, welcome to the webinar of 2021 Smart Machinery Overseas Promotion Program. I'm Yong-Xiang, the General Manager of PMC. In our very first webinar, we want to introduce you to not just the future technology development and trend of Taiwan's robotics and EV industry, but also Taiwan's top-flight smart machinery technology and products. According to TrendForce, EV sales grew by up to 20% in 2020, and this number is expected to reach 40% in 2021, showing how heated the EV market is. Taiwan's component manufacturing is developing fast. Not only do we have a complete EV component supply chain, but we also achieve actual results with our international partners, including being an important supplier for Tesla in terms of EV components. All of these have contributed to the advantages of Taiwan's manufacturing industry in the EV industry chain. The webinar invited Taiwan's most representative robot manufacturers to provide in-depth discussions on the technical trends and market development of electric vehicles. HIWIN Technology's IBS Intelligent Boss Group, for example, has been widely used in EV steering and servo brake system, and it is also taking up with a major European automaker for further cooperation. World Computing Technology provider DFI's in-vehicle application has joined Foxconn's MIH EV platform, developing towards the EV and OE market. Techman Robot, a supplier to well-known European automobile manufacturers, has recently entered the Japanese market, providing collaborative robots for vehicle inspection. Taiwan is on its way to become a global leader in smart machinery as well as automation and robotics technology, and it is definitely an important intelligent partner for cooperations worldwide.
Thank you, Mr. Lai, for the inspiring remarks. I know everyone must be looking forward to meeting our star speakers today. And now we will officially begin today's forum. For the first session, we are honored to have Assistant President of HIWIN Technology, Mr. Wen-Jia, to be our speaker. Mr. Wu is an experienced product development engineer for linear motion components and has deep knowledge for the application of motion systems. He set up the Industrial Robotic Arm Department within HIWIN, engaged in the development of automation, and has participated in a great number of automated assembly line projects. Today, he will talk about the smart manufacturing system for electric vehicles. Please welcome Mr. Wen-Jia.
Hi everyone, I'm Josh Wu from HIWIN Technology. It's a very honor for me to be here today to participate in this webinar. Today, I'd like to talk to you about the smart manufacturing system for electric vehicles. This is the outline of my presentation. To begin with, I will spend a little bit of time to introduce HIWIN Technology. HIWIN is currently highly involved in the electric vehicle industry. For the second part, I will talk about the changes and trends that I think electric vehicles has brought to the industry. Then the third part, I will introduce some of the main smart manufacturing technology that we have been providing in response to this trend, including semiconductor, automotive components, and welding process. And from these three aspects, I will also further illustrate the overall development trend of electric vehicles. And after that will be the conclusion. First of all, allow me to briefly introduce HIWIN Technologies. HIWIN is a corporate group consisting of HIWIN Microsystem of Iterbrite, Matrix Precision from the UK, and Megafabs from Israel. All these companies specialize in certain domains. HIWIN Technologies concentrates on mechanical components. HIWIN Microsystem focuses on electrical parts. Matrix is dedicated to manufacturing machine tool and gear grinding machine. Iterbrite endeavors to develop PV technology, and Megafab specializes in motion control system. These products all individually played a part in the industry chain of electric vehicles, and that's also what contributes to the advantage of our corporations. Next, I'll use few pages to introduce some of our key products. And firstly, as you can see, the man in the photo is Mr. Zhuo Yongcai. He is the founder of the corporate group. Alright, first, let's take a look at HIWIN Technologies products. HIWIN mainly provide mechanical components, such as ball screws, linear guideway, single-axis robots, bearing, reducers, rotary tables, and robots, which is what my department is responsible for. And also, HIWIN provide medical equipment. These mechanical components are closely related to the development of electric vehicles. Our ball screws and bearings, for example, have been used in the electric steering system of EVs. And for many auto parts processing equipment, ball screws and linear guideway are also involved in the making of machine tool. In addition, a great number of turbine blades also use our rotary table for cutting processing. As for robots, it's without doubt a very important part of automation in intelligent manufacturing. This speech was originally intended to be more direct, as I could use our products to draw a clear illustration of our connection with the electric vehicles. But due to the fact that we have signed lots of non-disclosure agreement, it is not allowed for me to share too much about the brands and the clients that we have cooperated with. So in that case, I will focus more on the topic of intelligent manufacturing. Next, let's move on to Microsystem. Microsystem also uses the brand of HIWIN, and it mainly produces electrical products. As you can see here, linear motors, direct drive motors, controllers, drivers, bearing stages, and so on. All these products are also used in a wide range of industries, with most of them applied in the area of semiconductor and automation. But indeed, there has been quite many projects directly related to electric vehicles. And of course, all these fields are becoming a common trend for electrification in the future. Okay, let's get into the main subject. Let me briefly talk about how I see the development trend of electric vehicles. So, to combat climate change and serious air pollution, the world has announced successfully the time limit for stopping the sale of gas and diesel vehicles. There is actually a rather interesting point here, which is the development of electric vehicles, in fact, comes from the government's direct support. You can see that such statement is very strong. I listed a few countries here: the United Kingdom, the European Union, the United States, and Japan. All of them have all declared to stop selling diesel cars, starting from 2030 for the UK and EU, 2035 for the US, and 2050 for Japan. Still, stopping the sale of gas and diesel vehicles does not necessarily make electric vehicles the only solution. In fact, the technology of hybrid power and fuel cell are also being developed at the same time. So, we can say that EV is currently the most ideal option on the list, but technical development is still going on. So when it comes to the development trend of electric vehicles, Because of policies and the support from the governments, the trend is actually irreversible. And that is to say, we don't need to worry too much about it being a mere change in consumer behavior. What we, as part of this industry, ought to do now is to make possible corresponding actions to face the changes that come along. So, from my point of view, the popularity of electric vehicles will bring about several major industrial changes. What many people focus on is the charging system and the infrastructures after the electric vehicles being popularized. But today, I want to offer a different viewpoint to explain what impact the popularity of electric vehicles has had on other industries. Firstly, for example, electric vehicles use about 1,000 chips, which is 5 times the number of traditional vehicles. It's also said that there are about 150 different kinds of chips used in EVs, which can also explain the recent shortage of chips for products like MCU. Secondly, the mechanical parts used in electric vehicles are reduced by 30% compared with traditional vehicles, mainly on engines and drivers. Thirdly, the electric vehicles we see today are mostly sedans, but transportation vehicles may actually develop faster because their routes are more regular and can be controlled within a fixed range of travel time and distance. Therefore, it will be rather easier to develop their charging system as well as the charging process. So, these are the 3 main trends that I have observed. And based on these 3 trends, we also have had some experience regarding smart manufacturing, which are related to the semiconductor industry, the automotive parts industry, and of course, the future production of transportation vehicles. So next, I'll break down these 3 fields to give you a more detailed explanation. First of all, in the semiconductor industry, wafer robot has been very hot in the market since last year. And the reason for such popularity is that in the semiconductor industry, smart manufacturing is actually already a standard requirement due to its demand for precision, specificity, and value in manufacturing. This industry is already ahead of other industries in terms of equipment and technology. In this case, for those who want to step in the industry or take part in the production of related products, their equipment and technology certainly must be capable of reaching that standard. As what I just mentioned, robot, as a crucial part of smart manufacturing, is a key domain that our company has been focused on. Here you can see the 2 robots, which are 2 of our best-selling products, the RWS single-arm wafer robots and RWD dual-arm wafer robots. And on the left are their simple specifications. The biggest advantage of these robotic arms is their high stability and reliability. Since manufacturing wafers require factories to operate 24 hours without stopping, reducing its downtime and making the production process smoother and more stable, this becomes a must. Cleanliness is also an essential requirement. You can take a look at their well-sealed surface. The cleanliness of our wafer robots is class 100, and it's also something that distinguishes us from the other. This year, HIWIN released several new models for our wafer arm, and we still adhere to the spirit of vertical integration. More than 80% of the components in the wafer robot are produced by HIWIN, including ball screws, guideway, bearings, direct drive motors, servo motors, and controllers. This is also especially important in the semiconductor industry because of the high demand for efficient and effective maintenance and logistics support. Especially after this wave of shortage in the past 2 years, I believe many of you all become very afraid of this situation when materials and components are insufficient. And that's the reason why we hope to provide our customers with a safer and more reliable robotic arm along with a complete maintenance procedure through the vertical integration of our highly self-produced components. Besides that, HIWIN can also develop special end effectors for different usage needs. The video on the left is a ceramic end effector for wafer handling. The end effector can only clamp the wafer in an area no more than 2 millimeters, and all the middle parts of the wafer must not be touched. And this is an example of us making specific adjustment and development in response to the need of our customer. Okay, then let's look at the next video on the right. So, during wafer handling, sometimes you will need to do a simple flip action. And this flip action is actually very important for the smooth continuity of different manufacturing process. So, this is also a case in which we work with our clients to develop products that meet their needs. In addition to the wafer robotic arm, in order to provide more complete services to our customers, HIWIN have also developed extension function of eFan. eFan is an automated standard module for semiconductor. It's connected to the front end of the equipment so that it can be automatically shuffled between a variety of processing and testing systems. And what's the purpose of providing such a product? In addition to just providing robotic arms, we hope to put forward a more complete system service to the equipment manufacturers. eFan actually contains a lot of key subsystem components, including the control software system, pre-aligner, low port, robot, motion controller, linear track robot. And aside from the linear motion track, the robot, and the software, we're also planning to officially launch the pre-aligner produced by HIWIN in the second half of this year to match with the low port products. We'll continue to strive to maintain our spirit in development as well, for the purpose of giving our customers a more complete solution so that they don't have to worry about the follow-up maintenance. Okay, after the discussion on the semiconductor industry, next I want to talk about smart manufacturing for automotive components. Many people are rather worried about the role automotive components might play in the wave of electric vehicles, because electric vehicles do not require so many components in the driving part like traditional cars. So in that case, I think the automotive components industry is bound to face restructuring. For newcomers, this restructuring can be an opportunity. And for the existing manufacturers, it might be a time for transformation. In the past, most of the automotive components manufacturers usually followed and moved with the assembly factory. So if the assembly factory is in the US market, the components manufacturer will go with them to the US. But in the future, because of the number of components that are needed has been decreasing, the process of transportation, transmission, and production will become less complicated. So, this is a trend that I see. And that is, in the future, as long as the delivery is faster and the production cost is cheaper, then the orders can be obtained. So, in the automotive components industry, what I have seen is that many Taiwanese manufacturers actually get more orders, because as long as the demand and the specifications stay the same all over the global market, they can produce their products even quickly and efficiently. Okay, next I'm going to show you a short video. It's an automotive components manufacturer in Taiwan, and it is very popular, but I can reveal its name right here. So what this company produces is a component called bush. Normally in each car, there has to be installed with dozens of this bush. As you can see, the smart manufacturing here is in fact a very simple model. For automotive manufacturers, TPS is originally a management method that they have been accustomed to. So they are very familiar with this kind of integrity of movement and process between special equipment. So the smart manufacturing we develop for them is that we use robotic arms to do the repetitive loading and unloading actions originally done by people. Still, many people will wonder what's the difference between human force and robots in terms of production speed. Well, I can share a little story with you here. This customer was actually quite dissatisfied when he adopted the first system for the first time, because he felt that if simply use a timer to measure the whole production process, robotic arms actually perform not faster than human and even slightly slower. And he was also very hesitant about the later investment. Then, about a year later, he was actually very happy and willing to invest in the next few sets of equipment because he found that on the total number of production, robotic arms produce 15% more than the operators do. And that's because the operators need to rest. And there will be different situations happening as well. But there won't be any unexpected incidents for robotic arms. And they can always keep the production running stably. So, if the industry you are in have already optimized the original manufacturing process and just need an upgrade, then it's a simple way to do it. Next, I would like to share with you a rather special field. Many of you may not know that HIWIN Technologies is also involved in welding, and we mainly focus on the smart manufacturing for structural welding process. So, why do we have the idea of joining this field, and how is it related to electric vehicles? I don't know how many of you are aware of the policy that Taiwan is expected to replace 16,000 diesel buses with electric buses by 2030. Personally, I think this is a very smart policy because bus routes are fixed and the distances are manageable. The setting up of charging systems is also relatively simple because buses take shifts and rest at the same places. In that case, you only need to install the charging stations at several terminal stations, and you can switch to the electric range easily. Also, since buses start and stop driving frequently, electric buses can do a great help in the issue of energy saving and carbon reduction. Of course, the production scale of bus is smaller than that of cars. Generally, when producing cars, a large number of molds will be used to create sheet metal to do the spot welding. So if you had seen some car manufacturing videos, you might see a robotic arm holding a large spot welding gun to do the spot welding. However, the production scale of bus is relatively small, and the types of it are more. So it's much more difficult to use molded sheet metal. Most of the bus structure nowadays is welded by arc welding of square tubes. And anyone who has taken part in the process would know that square tube arc welding is terribly labor intensive, especially in the final full welding process, which costs numerous time and spirit. At present, Taiwan relies heavily on foreign workers in the field of welding. And that's why through the smart welding system, we hope to improve the quality of the entire welding process and also save manpower. So, as HIWIN starts investing in the smart manufacturing of structural welding, we of course also want to improve the past Japanese, European, and American welding systems. Welding is a relatively complex craft, so we must find ways to build the procedural knowledge into a system to make it easier to operate for our customers. So first of all, we use EtherCAT-based real-time communication to connect the robotic arms with the surrounding systems. The whole system is designed with 6 degrees of freedom and 3 external degrees of freedom. With a 9 degree of freedom structure, our customers can easily achieve further expansion and connection. The second part is that what HIWIN sells is not only robotic arm or welding, but we hope to help customers customize a complete solution. We're also very willing to provide supportive documentation and training so that our customers can maintain or even copy the system themselves afterwards. What we hope to do is more like promotion and education. And finally, We have already developed many peripheral modules for our customers to select and build their own professional smart welding system, just like building Lego. Now, let me briefly share with you an example. What you see is a common welding system for a rotary table. There is a robotic arm package, a torch, a workpiece with fixture, and also peripheral devices and the system platform. For the whole system, you only need a forklift to move it around. And because it has two workstations separately in the front and back, so when the robotic arm is welding, you can do the assembly on the other workstation at the same time, so the producing process can continue constantly. What we are currently focusing on is arc welding, which is the so-called MIG and MAG welding. From what we have seen, the technology is progressing more and more rapidly and will possibly replace many traditional filler metal welding process in the near future. Here you can see the specifications of our different robotic arms. What we have put a lot of focus on is the working range, with the range up to 1.8 meters. And basic welding with such a working range can actually have a higher variability for workpieces and can also respond to more different kinds of workpieces, especially the structure for cars, which is relatively larger in volume. For the welder of our welding system, we have currently cooperated with Binzel. It's a German company specializing in welding automation. So the welding machine that we chose at the beginning was said to be equipped with all the functions that are currently needed on the market, and we enhance them. For example, we include the low spatter function as a standard in this iMake Arc series on the left. In addition, for the categories of mild steel, stainless steel, and aluminum alloy, we directly integrated them into a model called iMake Pulse. Both of these models are of higher quality and standard compared to all the models that were sold in the market. And we designed them in a way that enables our customer to respond to more material changes and more welding methods in the future. Next, let's take a quick look at this video. What you see is an animation video for product simulation, and it's totally free for customers to use. Okay, so now let me use these videos to share with you our proposals to the customers. So when evaluating the welding process, we need a customer to provide us with the process as complete as possible. And then we will help them to calculate the cycle and capacity and make comparison with the manpower. So what we call as smart manufacturing is not simply to replace labor with machine, but to find the best way of collaboration between machines and people, so that the latter can engage in the most suitable work for him or her without unnecessary burden. So from both Proposal 1 and 2, we can see that the assembling process of this tool is manually done by manpower, because the assembly is usually more complex and requires dexterity. And after the work is completed to a certain degree, the robots will then continue the welding process, which may take longer time and cause eye strain. In this case, both the flexibility of the workpiece and the precision of the robotic arm can be achieved. Okay, the next video is a simulation video of bus chassis welding. It's one of the cases that we encountered before. As you can see, this is a frame of bus chassis, and there are lots of blind spots there. This angled area makes it very difficult to do the welding. If you use a robotic arm, it can reach different narrow angles because of its flexible structure. But you can imagine that if this is operated by a human welder, it will be terribly time-consuming and also more possible for the welder to get hurt. And that's why we believe that in the future, this kind of smart production technology will play an important role in the field of electric transportation, and it will also promote the development of electric buses in Taiwan. And as for the software, we wanted to involve technologies like tablet or touch screen to go with our interface, integrating the procedural knowledge of professional welding technology in our controller so that our robotic arm can be equipped with not only excellent control ability, but also the procedural knowledge of welding. So, one very important point here is that performing repetitive and consistent movements is very easy for robotic arm. So it can repeatedly do the 3 weaving patterns that we designed. But in the past, when it's people who needed to perform such tasks, like increasing the weld bead width and metal fill, it's very heavy work. And the operator needs to be very patient to repeatedly draw the lines. Under such circumstance, quality problems will surely happen. So using robotic arm to do welding can keep manpower from having to do repetitive actions and at the same time improve the overall quality. In addition, we have also incorporated a contact calibration recovery function in the system. We can see that in the video on the left, the welding line for the torch has deviated from the track. So we use TCP to formulate a calibration method, which is similar to the coordinate measuring machine. So as you can see, after the calibration, the welding wire is back to the center. And if accidents happen in the process of mass production, this function allows the equipment to quickly recover and continue the production. This is another circumstance, which we call resuming the welding process. It usually happens when there is a hold request, which could be checking the overall condition or the weld bead during the production process. So what we do is that we stop the welding first, press pause to let it move away for some distance, and then we can observe the condition of the weld bead closely. And after that, the welding will be resumed immediately because continuity is of great cruciality in the welding process. If it's interrupted for too long or the condition is not continuous, there will be defects in the whole welding track. Next, when designing the control interface, we also consider what would be the more convenient and simple method for the actual operator to work with. What we do is that we used a rather simple workstation setup, and we use buttons to replace the complex process. The operator only needs to press the buttons when operating these welding processes. In brief, we hope the welding system in the future can separate the work of engineers and operators and achieve work division. Operators only need to focus on assembling work pieces and keeping track of the welding quality. And the welding process can be set up by engineers in advance through offline simulation and digitalization, as well as their experience of smart manufacturing. And finally, I would like to share with you some videos of welding. As you can see, after we started to use the external drive shaft, the robotic arm could quickly achieve multi-axis simultaneous motion. And from the angle it works, we can also see that it's almost without any difficulty for it to reach the blind spots of any workpiece. But for human welders, this would be a tougher angle at which they will need to bend a lot while having to keep their eyes from getting hurt by the welding light. It's just very hard. Okay, the next video is a base support component, and its material thickness is about 20 millimeters, and it's a T-joint welding bead. As you can see, the new welding machine is equipped with better spattering function and faster speed, and its performance has been better and faster than manpower as well. The last video is a medical system that performs overlap joint welding with a 2 millimeter thickness. For this system, lots of emphasis is placed on the appearance and the visual perception of the entire welding process. In the past, to achieve such goal of high quality, the bead must be polished after the medical equipment are melted manually so that it looked better on appearance. So when we were developing the robot welding for medical system, we managed to eliminate the bead's need of polishing and made the whole appearance visible so that the customers can directly do production, which is also really in line with our concept of green production. Okay, we are reaching the end of today's speech, and let me briefly make a conclusion. The development of electric vehicles is without doubt a huge change for any industry, and I think many people will agree that usually a change means a crisis. But I also believe that it can be a turning point. The original intent of smart manufacturing in Industry 4.0 is to use smart factories to solve the problems that the world is facing right now, such as pollution and wealth gap. And in my speech today, I also try to share with you some examples of how it can be and how it has been done. When facing different changes in the industry, smart manufacturing can bring different effects through different methods, and HIWIN will continue to strive to develop new products and solutions in this direction. We look forward to becoming your best partner on your journey towards smart manufacturing. Once again, thank you for your time. Here are some links for our website and product introduction. If you have interest in our products or want to discuss more about what I just said in the speech, please feel free to contact us. Thank you very much.